Alrighty, here we go with Sig Test 7, number 12. The slope, when it's y equals, is just the number that's in front of the x. The y-intercept is at 0, -5, and it's right there. So over here you have 10, so that's 0, 10, and then your slope would be -4. So to graph this guy, you start off at the -5, the 0, -5, and the rise over the run. So you rise 1, run over 1, 2, 3. Rise 1, run over 1, 2, 3. Or you can go a negative direction and another negative. A negative divided by negative is a positive. So you can go -1, -3, -1, -3. This slope is negative, so it should go downhill from left to right, just like you read from left to right. It goes downhill left to right. So this -4 is the same as -4 over 1. So you go down 4 over 1, down 4 over 1, down 4 over 1, negative over positive, negative over positive. Or if you're going back the other direction, you go positive over negative, positive over negative. Both give you a negative slope. Now we're going the other direction. So when I look at this guy, I see it has a y-intercept at -4, 0, -4, and it goes up 3, 1, 2, 3, and over 1. So it rises 3 and over 1. But we don't write 3 over 1. We just write 3. And it's positive since it's going uphill from left to right. Just like you read, left to right, it goes uphill. From left to right, this one goes downhill, so that's why it's a negative slope. That was the number one mistake I saw. Goes down 2 over 3. Down 2 over 3. Doesn't matter which 2 points I pick, it goes down 2 over 3. Or I could go down 4 over 6, but that reduces to 2 over 3. And the y-intercept's at 0, 4. This one, graph both equations. So 13, I put a dot at 0, 13, and I went up 2 over 1 because the slope is 2. Or I can go down 2, back 1, down 2, back 1, down 2, back 1, down 2, back 1, down. So I got this line, -15. And the slope is -5. So up 5, back 1, up 5, back 1, up 5, back 1, up 5, back 1, up 5, back 1. And they intersect at -4, 5. So when I solve it algebraically, I better get the same answer. Because that's what it means, is to find where they're both the same. This is where both equations are the same. It's where the graphs are the same, right here at that point of intersection. I substituted in for that y. And that's how I got the 2x plus 13 equals -5x minus 15. I solved it by adding 5x to both sides, subtract 13 from both sides, divide by 7. That gives me -4. Plug the -4 to one of the equations. It doesn't matter. They'll both give you the same answer. That's a way to check it, so plug it into both of them. -8 plus 13 is 5. So -4, 5 is where they intersect. See, it's the same. Flipping it, flipping it, flipping it, flipping it. Most people got A correct. Combine like terms, you get x, and I subtracted x from each side. Combine like terms, I get 48, divide, and I get 8. Substitute in my 8 for the x's, and just do the order of operation to check, and I got 56 equals 56, which makes it true, so therefore I did it correctly. Distribute, that gives me a -6x. 6x minus 6x, gone, that's 0. -3 times a -5 gives me a positive 15. Negative times a negative is a positive. Distribute again. Many people lost that -2 on the test. Combine like terms. Combine like terms. Subtract 15 from both sides, and I got 0 equals x. The new problems this week. I subtracted 2y from each side to get all my y's on one side, because I'm solving for y. Get them all on one side, and I added 6x to get rid of the 6x on this side, or the -6x on this side. I added 6x, so that's where he came from. Combine like terms. I need the y by itself, so I divided by 2. 2 divided by 2 is 1y. We just don't write the y because we are lazy. divide, divide, 3x minus 10, and it asks for the y-intercept, and that's 0, negative 10. Oh, when I was making the test, I kind of screwed up because I wanted one of them to be there, but it didn't. X and y. Substitute in 4 for the x and 0 for the y, and it came out to be not true. Negative 4 is not equal to 6. Did the same thing here. Plug in my x, plug in my y, and not true. Same thing, I just checked it every time. Multiplying these binomials. Remember, squared means 3x minus 4 times 3x minus 4. I use a little generic rectangle here. Some of you use some foil. I don't care, but you'll get the same answer. 3x minus 4, 3x minus 4. 3x times negative 4, negative 12x. Just find the area of each one of these little guys. 3x times 3x, 9x squared. 3x times negative 4, negative 12x. Negative times a negative is a positive. Combine like terms, that's how I got the negative 24x. There's the 9x squared and the 16. So this guy is equal to this ugly guy. Watch out for these negatives. That's where most people went wrong. Find the area of each one of them. So you multiply to find the areas. Length times width. Length times width. Combine like terms. And there you go. And the last one's a little bigger and uglier, but it's the same idea. It's 2 by 3, so I made a 2 by 3 rectangle. X times x squared is x to the third. And the negative is where most people went wrong. You got to watch out when you see negatives. So x squared times negative 3 is negative 3x squared. Combine these like terms, and that's how I got the negative x squared. Combine these like terms, and that's how I got the negative x. And of course, he's all by himself. Alrighty then.